Here is 90. So I'm back at 0 at both these places. So I'm going up to 1, down to -1, down to -1 and up to +1 and over. Okay, so really rough like I said, but that's showing my range between -360 and 360. So I want to know when sine theta is equal to 2/3. Well, 2/3 is about here. So I just look, where is sine theta equal to 2/3? Well, there's a point here, there's a point here, there's a point here, and there's a point here. So I have 4 solutions, okay? One is between 0 and 90 degrees. One is between 90 and 180. The third one is between -180 and -270. And the fourth one is between -270 and -360. So my answers should reflect what I've shown here on the sine curve. So then we take it to the Cartesian plane, and the rest of this really should be a review from last unit. So we're trying to find where sine theta is equal to 2/3. So sine theta is equal to 2/3. So this is positive. So there are 2 quadrants in which sine is positive, which is quadrant 1 and quadrant 2. So again, you can use the cast rule or think about where is y positive, because that's where sine is positive. So it doesn't have to be accurate. We just have a terminal arm here, and here's our first theta, 1, and then a terminal arm here, and that's theta 2. But don't forget, you have to label your beta, because that will be important. Now, in the first quadrant, beta and theta 1 are really the same thing because it's an acute angle, but we can label it anyway. These two are equal. It helps us to understand what's going on. So now we have this beautiful diagram. So we're going to use our calculator for just general knowledge of exact values to solve this, okay? So you should be writing this underneath here at step 3, but I think it's useful to have this diagram up while I'm solving, so I'm going to solve it up here, but you can use the space below to actually write this stuff. So the first thing we have to do is find beta, okay? So beta, we just undo sine to find beta, right? We find the inverse sine of 2/3. Remember, always taking the positive value. If this was -2/3, we would still be finding the inverse sine of positive 2/3 because beta is always positive. And that gives us 41.8 degrees. Make sure you do it in your calculator, you get the right answer. So therefore, theta 1 is just equal to beta. So it's 41.8 degrees. And like we said up there, the first answer was between 0 and 90. So that's our first answer. Yay! Theta 2 then, it's right here, that's 180 degrees minus beta. So 180 minus 41.8 is 138.2 degrees. So that falls, again, within the range that we determined from our sine curve. So now you're thinking, well, how do I find the negative ones, the one that go in the other direction? Well, for those, you have to go this way. Okay, so this is theta 3, and that's theta 4, okay? So theta 3 is equal to, here we go, -180 plus beta, or minus beta, like we're going even further negative. So minus 180 degrees, and then minus another 41.8. degrees gives us minus 221.8, and then theta 4 is -360, but then we take off beta again to get there. So that's minus 360 minus 41.8, so negative 318.2 degrees, okay? Because we're taking 360 minus beta, okay, 360 minus beta, but we want the negative version of that. So that's why I put the negative out front with a negative sign to show that. So that's step 3. So we solved it. We found all 4 solutions. Okay, 1, 2, 3, 4. They correspond to the terminal arm on the Cartesian plane, but now we also understand that they correspond to points on the sine curve within those given ranges. Okay? All right, one more example. Green one's a bit tough to erase. Okay. All right. Okay, so here we get the case where we have something we have to rearrange. Okay, so given y equals 6 sine of 10t, solve for t, when y equals 5.3 and between 0 and 15. Okay, so step 1 is to rewrite the function as sine of the argument. So the argument is whatever we're taking the sine of. So in this case, 10t equals just a number. Okay, so 6 sine 10t equals 5.3. But we don't want the 6 outside of here. If we added something here, we wouldn't want that either. We just want sine and the argument, and then one number on the other side. So we divide both sides by 6. So the sine of 10t equals 5.3 over 6 if you need to show that step. So that gives you sine of 10t is equal to 0.8833. Do not round, okay? So you can't divide by 10 because 10 is in the argument. You're not multiplying sine of t by 10. If you were, you would divide by 10, but you're taking the sine of 10t. So whatever is in the parentheses there, whatever you're taking the sine of, you can never divide by that. Okay, so what do we do then? We let u be equal to 10t. We always just choose u. I don't know why, that's just the standard thing. Okay, and let that be our argument. So now we have sine u is equal to 0.8833. Okay, so this is positive. So it's going to happen in 2 quadrants. In this quadrant, so here's u1 and here's u2. Okay. Here's beta, they're equal to each other, right? So we wanted our t to be between 0 and 15, but we want to know what is our u between. So we multiplied t by 10, that's the argument, okay, that's what u is. So because t is multiplied by 10, so is the 15 to give us 150, and so is the 0 to again give us 0. So we're solving this between 0 degrees and 150 degrees. So again, I did that by, I took the range that was given to me, which is in terms of t, and I transferred it to be in terms of u by doing what u does, which is just multiplying t by 10. So I'm only looking for u values that are between 0 and 150. So this for sure will give me a solution, but this one may or may not, because this is between 90 degrees and 180 degrees. So if it's after 150, between 150 and 180, then I wouldn't actually include that in my solution. So now we have to do some work and see. So now you can go to step 3, but again, I'm going to show it in this space just so I can refer to the rest of my work. So now it's just like the other question until we transfer back to t. So u is the inverse sine of 0.8833, which gives us 62 degrees. Sorry, that's not u, that's beta. Okay, so therefore u1 is equal to 62 degrees, and u2 is equal to 180 minus 62. Write that down if you need to. it's 118 degrees. 180 minus our beta of 62. So these are both valid answers. Both my 62 and my 118 fall between 0 and 150. So that means when I convert them back to t's, both of those t's will fall between 0 and 15, if I did it right. So now, I just set these each equal to 10t because that's what u is equal to. So 62 degrees equals 10t, so t equals 6.2, okay? And 118 degrees equals 10t, so t equals 11.8. Again, I just divided by 10 to solve for t. So what does this mean? This means that, therefore, these are my two answers. These are the solutions to my problem. Okay? All right, so lengthy video. I know it was a lot to take in. I really hope that you learned lots. I really hope that you were able to follow the logic. If not, this is something that you will need to rewatch, and you will need to make an effort to not just know what to do, but to also understand what the reasoning behind the development of the sine curve. At least if you are continuing in university level functions, going to advanced functions, calculus, and beyond. Okay, so thanks for watching, and I hope you learned lots.